dear learners. I am Dr. Pawan Kumar Shukla, Professor and Head in the Department of Electronics and Communication Engineering, Noida Institute of Engineering and Technology. Today, I am going to discuss a very important topic in the subject antenna and wave propagation as long wire antennas. As the journey of practical antenna is going on in my last few lectures, I want to derive one very important aspect of the practical antenna design, that the elementary antennas which have been given in the form of Hertz antenna and Marconi antenna. Basically, these are the two basic fundamental forms of any kind of practical antenna. But if the configuration, if the design pattern and the different directional perspective of antenna are concerned, it is changing continuously. And in my today's lecture, you will see that how this journey of practical antenna is going on, because some very short length antenna, half wavelength dipole antenna, then folded dipole antenna, then the configuration of Yagi-Uda antenna, and in some form of high frequency antennas, these long wire antennas are also concerned. Long wire antennas are actually long. They are in the form of wires only, but the wires are so long. They are not limited to its wavelength or half wavelength only, because the multiples of their wavelength is also very important prospect of the directional characteristics of the antenna. In my today's lecture, the topic of discussion is based on this theory of antenna design. How the length of a wire, how the length of a conducting wire affects the radiation characteristics of an antenna, and these antennas are termed as long wire antenna. So, starting my lecture with the first slide, how these long wire antennas are introduced and what are the different definitions of these long wire antenna. The diagram which is given in this slide is basically the combination of different patterns, the combination of different lobes. Basically, these long wires are the representation of the antennas. So, the combination of the different lobes, the combination of the different radiation pattern in the different directions wires, when the wires are configured or oriented in the different directions, then definitely the radiation pattern in the different lobes in that radiation pattern are also deriving in the different directions. So, the resultant radiation pattern is in this form which I have shown in my first slide. So, an antenna is usually classified as a long wire antenna if it is a straight conducting wire with a length from 1 to many wavelengths, multiples of its wavelength. A long wire is a slow wave travelling antennas. It is the first travelling wave antenna. The long wire antenna is used when it is desired to radiate or receive predominantly from one direction. Simply, the long wire is oriented in that particular direction from which we have to receive the signals or in which we have to transmit the electromagnetic signal. So, long wire antennas, both resonant and non-resonant type, actually the length of the wire, the length of the long wire will decide the property of that long wire antenna in terms of resonance or non-resonance. Resonant antennas are having their own characteristics of radiation, and non-resonant antennas are having their own characteristic for the radiation purposes. Both kind of antennas are having their own construction, their own design prospect, and the different methodology to feed, to excite its electrical signal. So, it can be shown here like a very simple kind of long wire antenna. If this long wire is shown in this form, these are the poles on which a long wire is stripped, and simply the standing waves are generating within this long wire, and they are shown here, and simply this is the feed line. It means the excitation or feed system is placed here. It is associated with a coaxial cable or a feed line or two wire transmission line or balanced or unbalanced, any kind of feed system or excitation system can be provided here. And at this particular point, the resonant and non-resonant kind of antenna comes into existence. For a resonant antenna, it must be the length of the long wire which is complete in itself. It means there is no any kind of termination is needed. So, simply a resonant long wire antenna is shown here. This kind of resonant long wire, there is no any kind of termination is needed, and that is why the standing waves are generated. And when these standing waves are generated, it means the reflected waves and incoming waves both are propagating simultaneously towards each other, and when these both waves are travelling towards each other, that is why it is known as travelling wave radiator. And just because of this travelling wave characteristic, the radiation pattern of this resonant kind of long wire antenna is given in the form of a bidirectional radiation pattern, and this bidirectional radiation pattern is shown in this diagram, where you can see the pattern is bidirectional. This is one direction and this is one direction. The same kind of lobe, same kind of radiation pattern, same kind of side, minor, major, all kinds of lobes are present both the sides. That is why it is known as the bidirectional radiation pattern. If we talk about the characteristics of a resonant long wire antenna, this is given in this form. It means the electric field in a spherical coordinate system, that is r theta phi, it is given as 60 IRMS cos n pi by 2 cos theta upon 60 IRMS, and simply this is E r theta phi for the length of the wire. It means when n is odd and n is even, this particular number, this particular thing is given in the form of electric field, and this electric field component is existing here for the length of the wire. So, the radiation resistance is also given as 73 plus 69 log n base 10, and this 73 ohm is the standard radiation resistance for a half wavelength dipole antenna, conventional, most conventional. And when we talk about the electric field and the radiation resistance of the long wire antenna, these both are very important characteristics for the radiation purposes. Non-resonant long wire antenna. How we can define the non-resonance characteristic of a wire antenna? A non-resonant long wire antenna is terminated at one point with a resistance equal to its characteristic impedance. It means the long wire antenna is non-resonant when we have to terminate it at one of its end with its characteristic impedance. That is why the length of the non-resonant antenna may or may not be integral multiple to the half wavelength. And simply when it is terminated at one end, it means the backward waves are not generating, and when only one directional waves in incoming waves are generating from one end, then the standing waves are not here, and when the standing waves are not here, so the directional pattern, the radiation pattern is only unidirectional. And this is the simple significance of the existence of unidirectional radiation pattern. It means no reflected wave, no backward wave, that is why there is no existence of standing waves. The angle of the lobe vary with frequency even though the pattern remain unidirectional. This is the construction and this is the design prospect of the non-resonant antenna. As I have already mentioned that non-resonant antennas are terminated at one of its end. It means this is the characteristic impedance Z0, and simply the feed system is given from one point and the termination is done at the other end. So, the existence of standing waves is not here, and the length of the antenna is not complete multiple, or it may not be. So, the resultant radiation pattern is shown in the form of unidirectional radiation pattern like this. This is the unidirectional radiation pattern only in this direction, and this is the termination with its characteristic impedance. These are the basic properties of non-resonant long wire antenna, and due to resonant, the bandwidth of resonant antenna is less compared to non-resonant antennas. Advantages and disadvantages of single long wire antenna. If we consider only one single long wire antenna, then the greatest advantage of single long wire antenna is its simple structure. There is no variation, there is no angle of elevation, so it is straight and simple. Disadvantage, the directivity may be low because there is no any configuration, because there is no any design. Its side lobes may be high and the angle of the main beam is controlled by its length only. These drawbacks of a single long wire antennas are removed by using the array of wire. So, the different designs are proposed to form the different kind of long wire antenna. We have to understand what are the limitations of a single long wire antenna, because we have to eliminate all those limitations to get better directional characteristic in the case of long wire antennas. So, what are the variations which can be done in the case of long wire antennas to form different types of antennas? They may be in the category of resonant antenna or they may be in the category of non-resonant antenna. For some applications, a single long wire antenna is not very practical because its directivity may be low, its side lobes may be high, and its main beam is inclined at an angle which is controlled by its length, and it is sometimes it may not be desirable. So, the first and very important design prospect is done, changed, modified in the form of V antenna. V antenna, it is in the form of V, and V antenna means this is a single wire which is given the shape of V, and here you can see that this is the feed line and the wires are adjusted like this to form a shape of V. V antenna consists of an array of two wires. The feed line connected to one end of each wire. The length of wire and angle from axis of antenna are equal, and the plane formed by the legs of the V is parallel to the ground. So, simply the construction of the V antenna is like this, and the installation of that V antenna with respect to ground and its leg is given in this picture. You can see here that this is the V antenna and this V antenna is grounded at this particular point. These are the two wires. So, finally, the radiation pattern of this V antenna can be either type, resonant type or non-resonant type, and resonant type, non-resonant type, both kind of V antennas are configured here, and the resultant radiation pattern is shown in this second category. It means this is the resonant V antenna and this is the non-resonant V antenna, and simply we have shown the radiation pattern, how this radiation pattern is existing in this form like this, and this is in this form, bidirectional and unidirectional radiation patterns. Some of the design constraints for the V antenna are given here, and these design prospects with respect to its parameters. What is the angle between the two wires, and that angle is known as the included angle, and this angle defines the radiation characteristics and the radiation pattern of the V antenna. Increasing directivity of V antenna, how the directivity can be increased in the case of V antenna. Directivity of non-resonant antenna is more than the directivity of resonant antenna, because the non-resonant antennas are simply they are terminated at its one end. That is why these are simply this is the simple case of unidirectional radiation pattern. So, we can say the directivity can also improve by using array of antenna. Array is a word in the antenna theory which is used to enhance the directional characteristics of an antenna system by combining two or more similar kind of antennas with each other. In the same manner, this array of V antenna is designed, and if one V antenna placed at an odd multiple of the half wavelength in back of the first and two are excited with a phase difference of 90 degree, the structure act like end fire array, and this increases the directivity of the whole system. It means the antenna system is having better directional characteristic. Like V antenna, there is one more configuration in the same manner, that is known as inverted V antenna. Flat V antenna is required 3 vertical support but inverted V antenna requires only one support. And in this particular aspect, in this particular diagram, you can see that when this V antenna is shaped like this, inverted V, and in this particular design we have the characteristic of the better directional properties, and due to this matching only travelling wave, forward wave is present on the wire of the antennas, and this result the unidirectional radiation pattern. So, according to this particular diagram, this is the terminating impedance. It means this is also a case of non-resonant type of inverted V antenna, and we are receiving the radiation pattern in the form of unidirectional only. These are the disadvantages of inverted V antenna. The radiation pattern will have many minor lobes. The number of minor lobes are increased in the case of inverted V antenna. This lobes result in horizontally polarized wave transmitted in some directions. Some of the horizontal polarization and some of the vertical polarizations based on the orientation of the wires, based on the orientations of the different antennas. In the V antenna, the different two wires are oriented differently. So, the polarizations are also different. How these vertically polarized waves or horizontally polarized waves are produced by the different wires, and thus inverted V antenna will receive horizontally polarized wave from these directions. A very important variation of long wire antenna is termed as rhombic antenna. Rhombic antenna is also known as diamond antenna, because the shape of this antenna is like a diamond. This rhombic antenna is having the shape of a rhombus, and rhombus is having 4 wires, and these 4 wires are attached to each other like this, 1, 2, 3 and 4, and these are the connections, or you can say that only 2 wires, this wire and this wire. There are 2 wires and these 2 wires are pulled apart to form. These 2 wires are pulled apart to each other to form a rhombus. And these 2 wires at both the ends, at this particular end, these are excited or these are provided a feed system, and at the other end they are provided a termination, or they are terminated with its characteristic impedance. So, you can say the shape is rhombus, but the wires used to form a rhombic antenna are only 2. So, finally, we can say the radiation pattern of a rhombic antenna is a combination of all those 4 directional long wires, because the orientation and direction of these 4 wires are different. So, the combination of the radiation pattern of all those 4 wires is resulting in the radiation pattern of a complete rhombic antenna. So, simply this is the complete resultant radiation pattern in which all these, this one and this one, 1, 2, 3 and 4. These all 4 radiation patterns in one particular single directions are combined together to form the major lobe of the radiation pattern of the rhombic antenna. These are some of the basics rhombic antenna, how the rhombic antenna works and how the radiation pattern of the 4 directional wires are joined together to form the radiation pattern, to form the major lobe of the rhombic antenna. Rhombic antenna using inverted V antenna, it can also be framed, and by using the inverted V antenna we can also design a rhombic antenna in this turn, and this rhombic antenna is generally different in the terms of directional characteristic and the design prospects too. These are the advantages and disadvantages. Definitely rhombic antenna is a very good high frequency antenna which can be used for the purposes of multiple unit steerable array system, that is also known as MUSA system, and MUSA system is very good array system which is utilizing the properties of rhombic antennas to form the better directional characteristics. Beverage antenna is also very important variation of long wire antenna, and it is having the properties of a better characteristic of the radiation pattern and directional characteristics. So, this lecture was dedicated to all those wire antennas in which we can understand the length of the wire is basically varies according to its directional characteristics, its radiation characteristics, and on the basis of the length of the wire we can define and decide the application of the antenna for that particular use. So, thank you very much for watching this video. In my next video I will come with some more interesting topics of antenna theory. Thank you very much.